Let's go over two different examples for demonstrating how the law of conservation of mass works. For this first example, we have an equation that does not follow the law of conservation of mass, but we're going to use manipulatives so your students can see that the number of atoms on the reactant side does not equal the number of atoms on the product side. So the first part of this aligns with 8.6b, where your students are going to have to be able to count the number of atoms for each element. You can use the math blocks or beads or anything so students can visually see the number of atoms on the reactant side and the number of atoms on the product side. For this example here, after everything is counted out, we see that the number of carbon atoms are equal, we see that the number of hydrogen atoms are equal, and lastly, we see that the number of oxygen atoms are not equal. Next, we're going to look at the actual mass of the different formulas in a chemical equation. So now we're moving on from counting atoms and we're focusing on the mass of these formulas. So with this, we are going to have to make sure students do know how to do addition and subtraction and basically solving for x as they do in math. We're looking at the missing mass on one side of the equation, knowing both sides are equal. That missing mass added to what we already have should equal the other side according to the law of conservation of mass.